Every year, no fewer than 700 airplanes are delivered to airline companies all over the world by the aeronautic giant Airbus. And in 2020, the number will reach 1,000 a year. That's almost 3 airplanes a day. Manufacturing the most reliable aircraft at an ever-increasing pace is a major challenge, like piecing together a huge jigsaw puzzle.
An aircraft is made up of millions of different pieces. 1,500 suppliers work for the program in 30 countries.
And to supply production sites as quickly as possible, Airbus has chosen the ideal route, the air, thanks to its star aircraft, the Beluga. This model was specially designed to transport the largest airplane sections under construction, the wings and the fuselage.
The Beluga is an exceptional airplane, both in its form as well as in its loading system, which is unique in the world.
But with the arrival of the A380, the largest airliner in the world, another logistic difficulty arose. These huge aircraft sections required totally new handling.
The means of transport include special barges, special ships, and special trucks.
Against all odds, huge aeroplane sections travel across the continent.
The sea is beginning to get rough. The waves are 3 to 5 meters high.
Dangerous sailing conditions at sea. A barge passing under the dreaded Bordeaux Pontipier bridge requires meticulous planning.
The window of opportunity is sometimes limited to only 3 minutes.
These enormous sections end their journey in perilous conditions on the road, on oversized trucks, and in the dead of night. A stressful journey where the slightest mistake can cost millions of euros.
Imagine, a pair of wings cost 40 million euros each. 40 million.
On the road, on the sea, in the air, these extremely large convoys travel more than 2,000 kilometers across most of Europe to reach their final assembly site in Toulouse. A 21-day journey and 6 to 8 months of manufacturing, so that these A320s, A350s and A380s can finally take to the air. Toulouse-Blagnac, runways as far as the eye can see. Huge hangars and aircraft under construction everywhere. Since its creation in 1960, it's here that Airbus has forged its reputation as a giant. And yet, even with its ultra-specialized factories scattered across Europe, success was not a foregone conclusion. Perfecting the most highly advanced aeroplane in the world has proved an incredible logistic challenge.
There are 11 Airbus production sites dispersed throughout Europe. Each site has its own recognized expertise, and each site specializes in one type of airplane section. The tail sections are made in Hamburg. The central compartment and the nose sections are made in Saint-Nazaire. The wings are made in Broughton, and the tailplanes in Cadiz.
England, Germany, Spain, France. Aeroplane parts are brought from all over Europe to the assembly line in Toulouse, where the giant A380 and its little brother, the A350, are assembled. To ensure these deliveries, Airbus has developed 4 main means of transport: aeroplane, ship, barge, and even trucks. A complex system by which all the largest sections of the aeroplane can be brought to the main site in Toulouse. At Blagnac Airport, commercial airliners sometimes cross paths with another plane of a somewhat surprising design. A giant of the skies designed for freight called the Beluga. This custom-built plane is without question Airbus's main logistic strength. It allows the different Airbus sites to be connected in less than 2 hours.
The Beluga was built because Airbus is specifically a European company. The fastest way to transport all this freight to Toulouse and to manufacture the Airbus in time is actually using air transport.
In 2017, the Toulouse assembly line turned out almost 80 A350s and no fewer than 15 A380s. That's a plane every 4 days. Thierry Nerkam is a Beluga pilot. He's one of the privileged few to be at the controls of such a machine. There are only 5 of them on the planet, and all 5 are working exclusively for Airbus.
We're standing just next to a Beluga. This Airbus cargo plane is now capable of transporting most Airbus sections. It has a volume of 1,400 cubic meters, or the equivalent of about 100 small moving vans.
56 meters long from nose to tail. That's the length of an Olympic swimming pool. Its wings span 45 meters. And the plane is 17 meters high, the equivalent of a 7-story building. The dome-shaped nose has a giant 11-meter-high door that opens like the hood of a car. Through this huge door, many parts can be loaded, including extremely wide fuselage sections and even airplane wings.
We're now in the plane's hold. The Beluga is capable of carrying 2 whole pairs of A320 wings or 1 wing of an A350.
Wings of an impressive size. The wings of an A320 are almost 23 meters long and 10 meters wide. To deal with such giant parts, Airbus used the A300 as a base. This was their first commercial aircraft, inaugurated in 1972.
The innovative method used was to cut it at the level of the cabin floor so that sections could be put above it. The flight deck was also lowered so we could load cargo above it. Things all very specific to this plane.
This cargo plane was designed to hold up to 45 tons of freight. That's a total weight of 145 tons at takeoff, the same weight as an A300-600 airliner loaded with passengers. This Beluga is very busy indeed. 3 return trips are planned today to transport plane sections. It will make its first trip empty to Broughton in Wales, to the subsidiary plant that makes wings. Working at full capacity, the factory produces almost 120 wings a month. They're loaded as fast as possible. As soon as the wings are off the assembly line, they go into the Beluga.
So the time it takes to load a Beluga is 80 minutes. So that is our target from start to finish. The average at the moment for my team is around 67 minutes.
The moment it lands, it's towed into the hangar, where he can take care of the freight.
We'll then stop the aircraft safely on his dots. We'll pick the aircraft up with a tow barless tug with 2-way radio communication.
Once the Beluga is correctly positioned, a giant door shuts, protecting the unloading operations. Before opening the hold, the front end of the aircraft has to be totally within the hangar. It's only when it's protected from the wind and the rain that operations can begin in all security.
We receive approximately 60 Beluga landings each month to deliver our products into the final assembly lines.
1 to 4 wings are carried per trip in order to make the Beluga's trips as profitable as possible. To get the wings into the plane, an elevator capable of lifting more than 50 tons is used. It's called the cargo boarder. It's a large mobile platform.
The cargo boarder it varies in height. It can go all the way down to the floor from about 0.8 metres, but to load it onto the aircraft, we're looking at around 5 metres, 5.1 metres.
Thanks to this system, the load remains horizontal and can easily be slid into the Beluga's huge hold. Everything has been designed to avoid damaging the cargo during this delicate operation.
We're going to use rollers powered by electric motors. It's exactly the same type of system as used inside the Beluga. We can load a piece of up to about 35 meters long and almost 6 meters high. This is the maximum diameter, a central section of an A350.
Today's load is an A350 wing, the longest part the Beluga can carry, and with only a few centimeters to spare. Mission accomplished. The cargo plane can finally take off after a stopover of only 60 minutes. Destination Toulouse. Since 1994, the Beluga has been the main means of transportation for aircraft sections. But the arrival of the giant A380 in 2004 radically changed the situation.
When the A380 was launched, there was a great deal of discussion about how to transport parts of such exceptional size to Toulouse. Given the size of the aircraft, the whole transport logistics system had to be revised. The means of transport required were specific barges, specific ships, and specific trucks.
In Germany, 1,500 kilometers from Toulouse, a maritime adventure was to begin.
But the A380 sections didn't fit into the Beluga. That was one of the reasons we started the first maritime shipments in 2004. It was quite simply for these dimensional constraints that Airbus went maritime.
Hamburg in Germany is one of the major export ports for Airbus. Since the 2000s, these exclusive shipping services have made Hamburg a logistical nerve center for Airbus. The German aeronautic industry had originally installed itself here in the 1930s. The international port was then the third largest in Europe.
The port of Hamburg, the geographical situation is a quite unique situation because it's a port which is situated 100 kilometers to the North Sea. The size of the port is about 10,000 soccer fields.
The port covers an area of 8,000 hectares with dozens of kilometers of docks, where every year no fewer than 10,000 cargo ships come into port.
Hamburg has an overall turnover of 140 million tons of cargo being handled during a year and 9 million TEUs containers.
Several times a month, Airbus hires giant container ships to transport parts to factories in China and the United States. To supply the different Airbus sites in Europe, an entire logistics system has been set up. The ships make 2 trips a week.
We have an internal airport and an internal harbor. That means we're operating it with own personnel. Hamburg, we are around about 15,000 persons working, 7 days a week, 24 hours. We are transporting around about 300 sections a day. We receive 600 boats and 1,300 Belugas a year.
Here, plane parts begin their trip of over 2,000 kilometers. It will take them to 4 different European ports.
The main components that are built in Hamburg are the front sections, which is integrated towards the cockpit in Saint-Nazaire.
In Hamburg, fuselage sections for the A350 and the A380 are manufactured. These sections are more than 20 meters long and 10 meters high. To transport these gigantic parts, Airbus uses ro-ro vessels.
Ro-ro ships are large maritime freighters. They used to be used to carry perishables, such as bananas, things like that. They're ships you can get into easily. They frequently open backwards.
So Airbus had a whole fleet of ships custom built, such as this one called the City of Hamburg. At 126 meters long and 20 meters wide, this cargo ship with a volume of 1,450 cubic meters can accommodate multiple combinations of parts for the A380 as well as other new Airbus aeroplane parts. Thanks to this incredible space, the ship can carry 5 times more parts than a Beluga can. To operate as fast as possible both day and night, technicians use self-propelled modular transporters that eliminate the need for cranes. In shipping jargon, this system is called the ro-ro.
Well, with the ro-ro, roll-on, roll-off, we are much faster. It goes quite easy to load the components into the ship. The loading operation with the crane takes a little bit longer for us.
The parts are moved on a perfectly horizontal surface from the dock to the ship. To make the junction with the boat, a lifting platform is used.
It's 23 meters wide and can carry 200 tons. It can work as an elevator going up and down, and as well as a ramp that has a certain degree, depending on the Elbe, if it's low tide or high tide.
Thanks to this system, the main airplane sections can be loaded on the City of Hamburg in less than 30 minutes per part.
Today, the airplane parts being loaded are 2 central sections of an A350 and a rear section of an A380.
A 23-meter-long, 10-meter-high part. A meticulous operation where every centimeter counts.
It's possible to move a little bit, just 10 centimeters.
Each new load is a real jigsaw puzzle pieced together in the ship's hold. Between wings and fuselage sections, all of the most impressive parts on an A380 must be loaded aboard the ship.
Okay, excellent.
Each part is then securely fastened to the deck of the hold. Security in loading is crucial.
Ships carrying Airbus parts have a very large responsibility. Remember that when you're transporting a pair of wings worth 40 million euros apiece, it's obvious the captain will take the necessary precautions. And for this, everything must be absolutely secured.
For 3 days, the City of Hamburg plies the seas, traveling over 1,600 kilometers. After having crossed the North Sea and sailed down the Atlantic coast, the ship makes a stopover in Saint-Nazaire in France.
We're going to cross the North Sea and the English Channel We then turn at Ushant, heading to Saint-Nazaire, where we should arrive Friday morning at 4:30 a.m.
Navigation is difficult. A storm is brewing along the way which could delay delivery of the sections. Meanwhile, other sections are completing this dangerous maritime journey. At Pauillac, 50 kilometers from Bordeaux, all the sections of a giant A380 arrive one after another to be brought to the factories in Toulouse-Blagnac, a route full of pitfalls that follows the Garonne River.
The river presents certain problems. There are bridges in Bordeaux. The ships can't get under them. There are real obstacles to shipping, and that's why we've designed special barges to transport sections from Pauillac to Langon.
At this point, two river barges are used, the Breuil and the Brion. They are both 75 meters long and 14 meters wide, dimensions twice that of standard river barges.
Normal river barges are 38.5 meters long and 5 meters wide, so we're well above the norm.
Despite their size, whether they're loaded with two sections of fuselage or with a wing, one of the difficulties for these barges is to get under the bridges of the Garonne. To do so, builders used an unusual design: an adjustable lifting platform. This facilitates loading.
This is one of the two platforms on the Brion. It operates on the principle of a freight elevator. It's held by 4 points. Each of these 4 points has two pairs of cables that raise or lower the platform. This allows us to lower the sections to the bottom of the hold and to pass under the different bridges along our route.
And to lift sections and put them on this platform, technicians use a system called the multi-purpose vehicle, a huge 35-meter-long pallet on wheels.
To lift sections from the ship into the barge, we use an MPV, a handling vehicle with a thermic motor the strength of a truck. It has 96 wheels and is equipped with a hydraulic system that allows it to lift airplane sections from the ship and then place them in the barge.
The power produced by this hydraulic system can lift loads of up to 200 tons. The platform is controlled just like a remote-controlled car.
This airplane section weighs 63 tons, but the machine can lift a lot more. Right, put that down on the barge. Right, we're finished. I'll call the port.
When the A380 sections have been loaded and firmly attached, the barge is finally ready to leave. The journey can last between 8 and 10 hours. The average speed is 20 kilometers an hour. That's not very fast, but it's nonetheless quite a feat. Because over a good part of the journey, the barge is going against the current, and it's sailing against the wind, and that slows it down to an even greater extent.
The sections are massive, with a lot of surface. And this windage produces a resistance on the barge.
This force can destabilize the vessel at any moment. So these barges have to adjust their course constantly.
The Breuil and the Brion have a number of steering particularities. These river barges are equipped with 2 engines in the back and 1 in front. The captain uses these motors to steer the boat. They allow this 75-meter-long barge to position itself to within 20 centimeters.
After 4 hours of navigation, the convoy arrives at the notorious Pontipier in Bordeaux. The bridge is the most hazardous point of the journey. This historic monument was built in 1810 under Napoleon Bonaparte. It's 500 meters long and has 17 arches. Arch number 9 is only 19 meters wide. It's a delicate passage. The clearance can vary between 1 and 2 meters according to the level of the water. A perilous passage for the barge. At times, there are only a few dozen centimeters to spare.
When it's this narrow, it's important to remain calm and collected in order to best handle any situation.
When approaching the bridge, the barge has to wait for the green light. It can only pass under the arch when the water is at its lowest level, because even though it's 60 kilometers from the Atlantic Ocean here, the river is still influenced by the tides. The captain has a limited period of time, only a few minutes, in which to maneuver. He mustn't miss his opportunity.
Depending on the tidal coefficient and the seasonal discharge, this window of opportunity may be as short as 3 minutes. If missed, then the barge must turn back and wait for the next tide. 12 hours later, and we lose half a day.
A loss of time which has an enormous effect on Airbus's logistics and on the final assembly line. The barge's final destination is Langon, a small town about 50 kilometers from Bordeaux. Here, several sections of a giant A380 also await the green light in order to proceed to the Airbus assembly line in Toulouse-Blagnac, 200 kilometers away by road.
Parts arriving from all over Europe are stocked here. It's the final stretch before Toulouse.
On this parking area, a complete A380 is stopped. It's just completed a journey of over 2,000 kilometers by ship and barge. A new stage starts here, a 12-hour journey by road which will take 2 nights to complete.
Here we have 3 fuselage sections for a complete A380, as well as the tailplane and horizontal tailplane with the 2 wings. This constitutes a complete aeroplane. The convoy will transport a complete unassembled airplane to the final assembly line.
In order to transport all these sections by road, Airbus logisticians have developed trucks for extraordinary convoys composed of tractors and immense trailers.
We use 4-axle tractors with 650 horsepower. That's not much more powerful than a classic sports car. However, there's much more pulling power and uphill traction in particular.
The tractor unit is coupled to a trailer with at least 96 wheels arranged so as to distribute the weight of the load. This impressive articulated truck is 50 meters long. To ensure the security of these sections, worth tens of millions of euros, the technicians position the load on the trailer with extreme precision.
The trailers is 5 meters wide, but the section 6 meters 70. So we have to load it exactly in the center of the trailer. Otherwise, we'll have to pull forward and try again.
This alignment is essential. If not, the load is unstable.
We have a tolerance of 2.5 centimeters to the left or right. If we don't respect this margin, we're ruined. Everything would tip over on its side. It would be disastrous. This piece of airplane is very, very expensive.
The sections are securely fastened to the trailers. The trucks are now ready for a long haul. The departure is scheduled for 2,200 hours. At a speed of only 30 kilometers an hour, this oversized road convoy takes 2 nights to reach its destination, Toulouse.
The oversized convoy's route is 230 kilometers long. It starts at Langon and ends at Blagnac. It crosses 4 departments, the Gironde, the Landes, the Gers, and a part of the Haute-Garonne.
In a few hours, the roads will be closed, and the trucks will finally be able to start moving. As for the Beluga, time is of the essence. Flight time, 1 hour and a half. A crew of 3 is in charge of transporting the fuselage of an A320 to the final assembly line in Toulouse. An exceptional load in an exceptional aircraft that requires specific flight precautions.
One particularity is the way that the Beluga maneuvers in the air. No other aeroplane behaves like the Beluga, especially during the approach and landing phases, when crosswinds and turbulence play on its very large fuselage.
Apart from its greater sensitivity to the wind, the Beluga flies like an ordinary commercial airliner. It can land on a standard runway. At Toulouse-Blagnac Airport, its arrival is closely monitored by Vigie Airbus. A special control tower coordinates the flights of the corporation's fleet. A place unique in France, where tension is ever present.
Beluga 114 Delta Saint-Martin, whisky rappelé prêt à copier la Cléance.
On busy days, there are easily about 10 Airbus departures at the airport, and usually about 10 landings as well.
As well as controlling the takeoffs and landings of the corporation's fleet, the controllers also direct the movements of these giants on the ground.
From the Beluga's cockpit, the pilot's field of vision is rather limited. There's not much visibility, so we have to ensure that the plane can taxi to the holding point in total security.
It's only when the Beluga is actually parked in the hangar that the air controllers can finally relax.
To be right in the middle of all this, of all these airplanes, and they're very big planes, it's a bit like a video game where we organize our own little game. And when all goes according to plan, it's really a great feeling.
This afternoon, a section of an A320 has arrived directly from Saint-Nazaire in Beluga number 3. A team takes over to unload this gigantic part. An operation planned to the exact minute.
The different stages of the Beluga's unloading are the arrival of the airplane, its entrance into the unloading hall, the transfer of the sections into the hall itself, and eventually any pre-flight visits that are required before the plane can take off again. All this lasts exactly 100 minutes.
In order to ensure the safety of the cargo during the unloading operation, the technicians use a system of pressurized cylinders which stabilizes the aircraft.
This system is used to keep the plane horizontal and at the same height. A load may weigh from 15 to 20 tons depending on the part. When it's removed from the aircraft, the plane has a tendency to suddenly rise or fall. These cylinders compensate for the difference and ensure that the height of the plane is always the same.
To unload this giant fuselage from the hold, the team uses the same system of rollers driven by electric motors as it did for the loading.
Here, this fuselage section is being transferred to the loading bay. After that, it'll be lifted by an elevator and then put onto a trailer. Finally, it'll be sent to the final assembly line.
The Beluga continues its many trips across Europe, with a single and unaltered purpose for the last 20 years, to supply the assembly line in Toulouse as rapidly and continuously as possible. Airbus's logistical operations are a permanent ballet of hundreds of parts from the 4 corners of Europe. Even though the teams are perfectly familiar with the exercise, tension is always high. About 1,500 kilometers away from the unloading site of the Beluga in Toulouse, sections of an A350 as well as a rear fuselage of an A380 are being loaded aboard the city of Hamburg. For 3 days, this large ocean-going vessel will navigate the North Sea and the Atlantic Ocean. Direction, Saint-Nazaire, where the ship will stop over.
There are 2 delicate zones to negotiate. First of all, there's Calais. The Straits of Dover are narrow, and there are many ships as well as ferries crossing from France to England. Secondly, there's Ushant. During winter, depressions coming from the Atlantic cause bad weather. When we turn towards Saint-Nazaire, the ship can roll. We have to be careful there.
Jean-Yves Armand has been in command of this 5,500-ton mastodon for more than 7 years.
The wind speed is between 40 and 50 knots. That's about 72 kilometers an hour. The sea is beginning to get rough, the waves between 3 and 5 meters in height.
To deal with these dangers, the crew is ordered to hoist the anchors as high as possible so that they don't bang against the ship, which is being affected by the bad weather.
This bad weather is a little bit dangerous.
Yes, it's okay for the anchors?
Almost, sir, almost.
A few dozen meters away, the cargo is being closely watched by the chief engineer. Thanks to the specific layout of the ship, the cargo can be correctly loaded into the 1,450 cubic meters of the ship's hold, a real puzzle.
This entire area here was removed on 2 levels in order to create extra space. About 250 tons of steel were removed to make this supplementary volume. This mass is equivalent to an A380 fully loaded with passengers and fuel. Otherwise, the part on the left of the A350 couldn't have been loaded. There was a deck there which would have come to 2/3 of the wing's height and would have obstructed its loading.
During the loading phase, about 30 chains are placed around the 3 plane sections. As the ship moves at sea, the tension on the chains must be constantly verified. If not, the cargo might shift in the hold and be damaged.
It's really a large volume. The risk is that the cargo might shift during very bad weather.
This verification is repeated at least every 4 hours. Thanks to a camera on the bridge which is permanently focused on the hold, the captain can also keep an eye on this precious cargo.
We usually verify the cargo every 4 hours. But if the weather is bad, then there's a greater risk of the load shifting. So we increase the camera surveillance and we verify the condition of the chains.
On the bridge, everything is done to avoid the larger waves.
We're zigzagging in order to avoid the lateral roll. As the swell is lateral to us, we're zigzagging to remain more or less stable.
During a storm, the windage on this 30-meter high ship is substantial. To reduce the rolling, that is the lateral movement of the vessel, the captain relies on the stabilizers, an indispensable part of the ship's design. It consists of 2 horizontal fins that are located on the lateral flanks of the hull. When deployed, they compensate for the movement of the ship by reducing the amplitude of the roll.
These fins support the ship and keep it from heaving. They compensate for the ship's movements by reducing the roll. It would be 10 times worse without them.
Even in rough seas, time is not lost. The ship must complete its trip within the time allotted, 3 days maximum. Otherwise, the entire sequence of Airbus's logistics would be affected.
We've arrived at Ro-Ro Quay number 3 in Saint-Nazaire. We've traveled 1,500 kilometers in about 60 hours. That's about 25 kilometers an hour. Slower than a cyclist in the Tour de France. But we have transported our cargo, and despite the bad weather, we've arrived on time. It's really an honor to transport the parts of an A380.
The crews work at sea for 2 months. ensuring the transportation of essential Airbus parts, before finally taking a break. At Saint-Nazaire, a section of an A380 must be unloaded and transferred onto another Airbus ship as quickly as possible. This transshipment enables all the sections of an A380 to be regrouped in a single spot and to transport an entire aeroplane to Pauillac near Bordeaux. And from there, this amazing logistic adventure continues.
A rear section of an A380 is unloaded from the city of Hamburg. A fore section, made in Saint-Nazaire, and a central section are loaded. These three sections, as well as a complete rear horizontal tailplane of an A380, will be loaded and sent to Pauillac.
Aboard the ship are aeroplane parts worth several tens of millions of euros. For another night, they will continue their journey to the Garonne estuary before taking another form of transport. The next stage is ascending the Garonne, including a passage under the dreaded Pontipier bridge in Bordeaux. The captain of the barge must concentrate. The width of the arches of the bridge leaves only a margin of 1 meter on each side of the barge. It's also a very narrow passage for the cargo. The two sections of the aeroplane must be lowered as much as possible into the bottom of the hold. Thanks to this elevator platform, the cargo avoids hitting the vault of the bridge.
Everything's fine. We're going to pass under the Pontipier.
The barge is now ready to pass under the Pontipier. For the captain, it's a stressful moment, and people are watching from the bridge. Going slowly upriver for 4 hours at 11 kilometers an hour, this fluvial journey ends at Langon. It takes 4 barge journeys to transport all the parts of an A380 to Langon, about 100 kilometers from Pauillac. Upstream, the river is no longer navigable. After having made a journey of more than 3 days aboard a seagoing ship and a slow barge journey up the Garonne, these gigantic Airbus parts are now ready to undertake the last leg of their journey, this time over the roads of southern France. Expected departure imminent.
Je rappelle pour les vitesses en accoutumance au départ 15 km/h. Après, une fois que tout le monde est bien en place, je rappelle qu'avec les ailes, on peut rouler à 40 à l'heure. Et maximum avec les 6 lignes, on peut rouler jusqu'à 50 km/h. Les difficultés, tout le monde les connaît.
This 40-member team will transport the 6 sections of an Airbus 380 to Toulouse, a 12-hour journey towards the final assembly hall. 250 kilometers away in Toulouse, the road security teams are on the alert. Such convoys could not take place without surveillance and centralized coordination.
The operational system employed is sectional. That is, the convoy advances along 5 to 30 kilometer sections of the road as the normal traffic is blocked.
It's from this control center that the sections of the road are closed to the public. More than 40 barriers and 120 variable message signs are used.
Make sure you let me know when the convoy has left.
At exactly 10 p.m., the convoy starts. The sections that most worry the teams are the wings of the A380. More than 30 meters long and 15 meters high, they need to be transported very slowly. They can slow down the entire convoy. In order to move these delicate parts, a long experience as a convoy driver is needed. Thierry has driven these trucks for nearly 10 years now. But despite more than 200 trips, careful attention is still essential.
We have to be very careful about anything gyrating to the right or to the left at the roundabouts and intersections. The end of the wings swing out enormously. They pass very close to the streetlights. That's our main worry.
A wing that hangs 15 meters over the back of a truck runs the risk of hitting any obstacle on the side of the road. A few kilometers further along, the village of Gimont is the first difficulty of the route.
The problem in Gimont is the bridge. A sharp left turn, with the wheels scraping along on both sides and wide rotation of the wing towards the verge. Moreover, there are trees. Further along, there's a steep gradient that's rather tricky with all this weight. We didn't have to worry about anything, thanks to our guides who supervise everything from behind.
To fight against fatigue, the drivers take a 45-minute break.
It lets them relax a bit and prepare for the second half of the night, a much more technical and difficult phase. In a few minutes, we'll start to put pressure on them. They'll return to their vehicles, get in them, and attack this notorious section of the road. Mentally, it's the most difficult part. Levignac requires a great deal of concentration.
They've barely started, and the chief security officer is informed that a car is parked on the side of the road about 15 kilometers away, blocking the progress of the convoy.
Golf, X-ray, X-ray. I'm at the back of the convoy.
They have to get to the head of the convoy as quickly as possible. A kind of rally race is about to begin.
Well, here we're going to do something I love doing, but there are certain problems. We're going to overtake the convoy on a parallel road. I've got 3 kilometers to get in front of the convoy, and I'm going to use the cycle path.
Golf et Charlie, je suis en train de remonter sur Echo 8, Echo 6, Echo 7.
This is a moment of maximum concentration. An animal or a pedestrian could suddenly appear at any moment. So we're going to sound a little warning alarm.
While waiting for the tow truck, the whole convoy has to wait.
Ok, bien, on a Delta en face de nous. Je dois avec
They have to be quick. The road reopens to the public in 2 hours. After the car is towed away, the convoy can continue. It's now heading towards the narrowest part of its journey, Levignac. This is a particularly difficult passage for the central fuselage. With a diameter of 12 meters, it just squeezes by, with less than 30 centimeters from the rooftops.
Serrez-vous, serrez-vous, s'il vous plaît.
Now the drivers can calmly proceed to the parking area at the Airbus final assembly line in Toulouse.
The sections are usually delivered around 3 in the morning and are assembled the same day. There is only a 3-hour interval between the time we deliver the parts at Blagnac and the moment that they are needed on the assembly line.
Such precision on a journey that took so many days to complete, and with no delay in the final assembly of the plane.
Between the beginning of production and the end of the convoy takes 9 months, including 21 days of transport. The mission is accomplished. All the parts have arrived, they're on time and in good condition.
Parts which have traveled 2,000 kilometers by sea, river and road across Europe and France. Within minutes of their arrival, the main sections of the A380 are assembled in this immense hangar, capable of housing 8 A380s. As well as the larger sections, thousands of smaller parts are used to make an aeroplane. This operation takes place in a single combined station.
Oh, the operation is a real puzzle. Depending on the piece, they must fit together to the nearest millimeter, to the nearest tenth or even hundredth of a millimeter. To fix the sections together, I need 19,000 rivets. To fix the wings to the sections, I need 4,000 rivets.
Between the electric and electronic equipment, landing gear assemblies, and the engines, as well as the painting and interior fixtures, several more weeks are still needed before the airplane can finally transport its first passengers. Meanwhile, gigantic sections will continue winding their way across Europe by sea, river, and road. With the Beluga, ocean-going ships, river barges, and trucks, Airbus's logistics have continued to evolve along with the needs of the aeronautic industry, an internationally renowned expertise that today allows everyone to travel to the 4 corners of the Earth.